Welcome to video PN1. This is from probability notes. This is lesson 1, example 1, dealing with cards. First of all, you need to be familiar with cards. There are 52 cards in a standard deck. That's what we'll be using for the most part. The ranks are from 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. For our purposes, aces will only count as the high cards. There are 2 different colors. There's red cards and black cards, so there's 26 of each. As I said before, there's 13 different denominations or ranks, 2s through aces. There's 4 suits: spades, hearts, clubs, and diamonds. Okay, so let's do a few problems. First problem, you randomly select a card out of a standard deck. What's the probability that it's the ace of spades? Well, the basic probability formula is as follows. Probability equals number of successful outcomes over number of total outcomes. All right. There's 1 ace of spades, so there's 1 successful outcome out of a total of 52 cards. And that's the answer. Part B, what's the probability of selecting a red card? There's 26 red cards. I'll do it over here. Out of a total of 52. I'd like you to start with that and then reduce later, equals 1/2. Part C, probability of selecting a face card. The face cards are the cards with faces on them: jacks, queens, and kings. So there's 4, 8, 12 face cards out of a total of 52. So I can divide through by 2 and get 6 over 26. I could divide through by 2 again and get 3 over 13. Probability of a black face card. So the Jack, Queen, King of spades, the Jack, Queen, King of clubs, there's 6 of those. 6 over 52. Divide through by 2. 3 over 26. The probability of a jack. There's 4 jacks out of 52. I'll just simplify that to be 1 over 13. The probability of getting a 7 or above. So I've got 7s or higher. 7s, I'll just make a list. I could be 7, 8, 9, 10, Jack, Queen, King, Ace. Remember, aces are going to count high. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 4 cards in each rank, so that's 40 successful outcomes over 52. Again, I'll just divide through by 4 and get 10 over 13. All right, these are my newer things. They're not on your note sheet, but I added them. We'll be doing them later, but I just thought I'd throw them in now. Probability of an ace or a jack. Well, I've got 4 aces, 4 jacks, so combining them, I've got 8 successful outcomes over 52 total. And again, I could divide through by 4 and get 2 over 13. This next one you got to be careful. Probability of an ace or a club. Here's the common mistake. Oh, there's 4 aces, there's 13 clubs, so I've got 17 successful outcomes. Well, you're double counting the ace and the aces and the clubs. So I've got 4 aces, one of them's a club, then I've got 12 other successful outcomes, which are the 12 other clubs. So that's going to be the 4 aces, the 12 other clubs, 16 successful outcomes over 52. I could divide through by 4 and get 4 over 13. Let's leave our answers in exact simplified form unless otherwise specified. Later on, we will be talking about probabilities of various poker hands, flushes, full house, straights, straight flush, etc. We'll be keeping it to math and probability. We will not be learning how to gamble, count cards, etc. It'll just all be math and probability. So there you have it, how to apply probability to problems involving cards.